We spent decades and billions of dollars building the most sophisticated instruments humanity has ever known to peer into the nature of reality itself. The goal was straightforward: measure the universe, understand the fundamental laws, confirm what we thought we knew. We thought we had it figured out. The equations worked, the predictions matched observations. Reality seemed solid, tangible, real. The mathematics described a universe built on particles and forces, space and time, cause and effect. Everything made sense. Every experiment for 100 years pointed to the same conclusion. The universe follows rules. Those rules are written in mathematics, and mathematics does not lie. But that is not what happened. As scientists pushed deeper into the foundations of reality, they found something disturbing. The universe does not behave like a real physical system. It behaves like information, like code, like a simulation processing computational shortcuts to save resources. Deep in the structure of quantum mechanics, where reality should be most solid, physicists found pixelation, discrete units, digital behavior. And I do not mean small digital artifacts. I mean the entire fabric of space-time appears to be made of bits. Information bits, the same kind of information that runs on computers, the same kind of information that builds simulations. Here is why that scares scientists. If the universe is made of information that behaves computationally, then either we have discovered something profound about the mathematical structure of reality, or we have discovered that reality itself is not fundamental. It is simulated, generated, rendered like graphics on a screen. And if that is true, then everything you have ever experienced, every thought you have ever had, every person you have ever loved, might be nothing more than patterns of data running on hardware that exists in some other, higher reality that we can never access or understand. This is not science fiction. This is serious theoretical physics being debated at the highest levels of academia right now. And the more we look, the more the evidence piles up. The universe is profoundly, unsettlingly strange. Tonight, as you drift towards sleep, let me take you on a journey through the most disturbing idea in modern science. The idea that nothing is real, that the universe might be fake, that we might all be living inside the most sophisticated simulation ever created. Let us begin where this story truly starts. Not with computers, not with technology, but with a philosopher named Nick Bostrom, sitting in his office at Oxford University in the early 2000s, staring at a mathematical proof that would change how we think about existence itself. In 2003, philosopher Nick Bostrom proposed the simulation argument, suggesting that if a civilization becomes capable of creating conscious simulations, it could generate so many simulated beings that a randomly chosen conscious entity would almost certainly be in a simulation. This was not a wild speculation. This was a rigorous logical argument built on probability theory. The paper argues that at least one of the following propositions is true. 1. The human species is very likely to go extinct before reaching a post-human stage. 2. Any post-human civilization is extremely unlikely to run a significant number of simulations of their evolutionary history or variations thereof. 3. We are almost certainly living in a computer simulation. Think about what this means. Bostrom is not saying we are definitely in a simulation. He is saying that unless civilizations always die out before they get advanced enough to run simulations, or unless advanced civilizations never want to run simulations, then statistically speaking, we are almost certainly simulated. It is a trilemma, a three-way fork in logic, and all three paths lead to deeply uncomfortable places. Let us walk through the argument step by step. Places. Imagine humanity survives another 1,000 years, 10,000 years, 1,000,000 years. Our technology continues advancing at anything resembling its current pace. Bostrom asserts that it would be theoretically possible to create a machine with enough computing power to simulate both the human mind and the universe in sufficient detail to create a simulation that would be indistinguishable from our universe by the population of the simulation. We already run crude simulations today: weather models, economic forecasts, video games with artificial intelligence. These are primitively simple compared to what might be possible. Now extrapolate forward. A civilization even just a few hundred years more advanced than us would have computational resources we can barely imagine. A technologically mature post-human civilization would have enormous computing power. If even a tiny percentage of ancestor simulations were run, that is, high-fidelity simulations of ancestral life that would be indistinguishable from reality to the simulated ancestor, the total number of simulated ancestors, or sims, in the universe or multiverse, if it exists, would greatly exceed the total number of actual ancestors. Here is the disturbing mathematics. Imagine just one advanced civilization in the entire universe creates 1,000,000 simulated universes. Each simulated universe contains billions of conscious beings who believe they are real. The ratio of simulated beings to real beings is now 1,000,000 to 1. If you are a conscious being asking yourself whether you are real or simulated, probability says you are almost certainly simulated. You are one consciousness among trillions. The odds that you happen to be in the one real universe, rather than one of the million fake ones, is vanishingly small. Neil deGrasse. Tyson explained the simulation argument as the idea that we could be virtual beings living in a computer simulation. Astrophysicist Neil deGrasse Tyson said in a 2018 NBC News interview that he estimated the likelihood of the simulation hypothesis being correct at better than 50-50 odds, adding, "I wish I could summon a strong argument against it, but I can find none." Elon Musk has gone even further. Elon Musk has stated that the probability of reality being a simulation is 1 in billions, and that it is more likely than not that our existence is a simulation created by a more advanced civilization. But wait, there is a problem here. Actually, several problems, big ones. And scientists have been tearing the simulation argument apart since the moment it was published. To get a better handle on Bostrom's simulation argument, physicist David Kipping decided to resort to Bayesian reasoning. This type of analysis uses Bayes' theorem, named after Thomas Bayes, an 18th century English statistician and minister. Bayesian analysis allows one to calculate the odds of something happening, called the posterior probability, by first making assumptions about the thing being analyzed, assigning it a prior probability. The upshot of Kipping's analysis is that, given current evidence, Musk is wrong about the 1 in billions odds that he ascribes to us living in base reality. The first major problem is the assumption that conscious simulations are even possible. The first assumption is substrate independence. This is simply the claim that if we were able to model the mind with enough detail, then we would be able to create artificial minds capable of thought in the same way that we are. He goes further to assume that if we were able to simulate the entire world in sufficient detail and feed this world into the artificial minds we have created in the form of sensory inputs, the artificial minds would be incapable of determining that they were in a simulation unless they were given explicit knowledge of it by the creators of the simulation. But is consciousness substrate independent? Can you create actual subjective experience, actual qualia, actual what it feels like to be something, just by running the right computation? This is the hard problem of consciousness, and we have absolutely no idea how to solve it. We do not know if consciousness emerges from computation. We do not know if simulating a brain down to every neuron would create genuine experience, or just a very convincing zombie that acts conscious but feels nothing inside. The second major problem is computational limits. Such constraints are so demanding that all plausible approaches tested in order to reproduce at least a fraction of the reality we humans experience require access to impossibly large amounts of energy or computing power. This conclusively shows the impossibility of a matrix scenario for the SH, in which our reality is a simulation produced by future descendants, machines, or any other intelligent being in a universe that is exactly the one we think we live in. Think about what you would need to simulate every particle, every quantum interaction, every photon, every electron. The universe contains approximately 10 to the power of 80 atoms. Each atom contains particles. Those particles interact according to quantum mechanics. Quantum mechanics involves wave functions that exist in high-dimensional spaces. Conventional computers, including supercomputers, are inadequate for simulating quantum systems, with as few as 30 particles, because the dimension of the Hilbert space grows exponentially with particle number. To simulate even a small region of space with full quantum fidelity would require computational resources that exceed the computational capacity of that region itself. You would need a computer bigger than the universe to simulate the universe. This is a fundamental limit, not an engineering challenge, a mathematical impossibility. But wait, a defender of the simulation hypothesis might say, maybe the simulation does not simulate everything. Maybe it only simulates what is being observed. Maybe it renders reality on demand, like a video game that only loads the graphics for the room you are currently in. This would dramatically reduce the computational requirements. The universe as a whole does not need to simulate it, only the inputs to our senses. A simulation/virtual reality only exists in the minds of the players. There is no need to compute and render the contents of the room behind the closed door until my player's avatar calls for that information by opening the door and looking. This is just like the observer effect in QM, and also explains Wheeler's delayed choice quantum eraser. The physics rule set and the original set of initial conditions that defines this reality remains a probability distribution of the possibilities wave function until a conscious observer calls for the specific data, the which way data. Then a random draw is taken and the result is given particle behavior by being rendered into the player's data stream. Interesting idea, but there is a problem. Observational consistency across billions of light years, such as gravitational lensing, cosmic redshift, and thermodynamic decay, implies that even unobserved parts of the universe behave as if they are physically real. When we point telescopes at distant galaxies that have never been observed before, we find them exactly where general relativity predicts they should be. The cosmic microwave background radiation shows patterns from 13 billion years ago that match our models precisely. This suggests the simulation, if it exists, is computing everything, not just what we observe. Which brings us back to the impossible computational requirements. The third problem is unfalsifiability. One of the big problems with the simulation hypothesis is the fact that it is unfalsifiable. There is no way to prove it wrong. There are no conditions under which you could say that it is false, and that is not a good thing. The simulation hypothesis fails this test entirely. Any event or anomaly can always be explained away by saying the simulators wanted it that way. Whether the universe appears regular or chaotic, simple or complex, the explanation can always be bent to fit the data. This makes the hypothesis not only scientifically sterile, but epistemologically dangerous. Science works by making predictions that can be proven wrong. If your theory explains everything, it explains nothing. The simulation hypothesis can accommodate any observation whatsoever. Find evidence that seems to support it? The simulators program that in. Find evidence that contradicts it? The simulators program that in too, to fool you. It is like arguing with someone who claims an invisible dragon lives in their garage. Every test you propose, they explain away. The dragon is invisible to all instruments. It leaves no traces. It makes no sound. At some point, you have to ask, what is the difference between an invisible, intangible, undetectable dragon and no dragon at all? The simulation hypothesis, therefore, just is not a serious scientific argument. This does not mean it is wrong, but it means you would have to believe it because you have faith, not because you have logic on your side. And yet, despite all these problems, despite the computational impossibility, despite the unfalsifiability, despite the lack of any positive evidence, the simulation hypothesis refuses to die. Why? Because when physicists look at the actual structure of the universe, they keep finding things that look suspiciously like a simulation. Not because the universe is fake, but because the universe is made of something that looks a lot like information. And that is where things get truly strange, like information. In his 2003 article published in Scientific American magazine, Jacob Bekenstein speculatively summarized a current trend started by John Archibald Wheeler, which suggests scientists may regard the physical world as made of information, with energy and matter as incidentals. This is not metaphor. This is physics. Modern theoretical physics increasingly treats information as the fundamental substrate of reality. What is information? In physics, information is not the vague everyday concept of knowledge or data. Information has a precise technical meaning related to entropy and the number of possible states a system can be in. Thermodynamic entropy and Shannon entropy are conceptually equivalent. The number of arrangements that are counted by Boltzmann entropy reflects the amount of Shannon information one would need to implement any particular arrangement of matter and energy. Here is where it gets weird. Quantum mechanics states there is a smallest, discrete unit of energy, length, and time. Similarly, elementary particles, which make up all the visible matter in the universe, are the smallest units of matter. There is some evidence suggesting that our physical reality could be a simulated virtual reality rather than an objective world that exists independently of the observer. Any virtual reality world will be based on information processing. That means everything is ultimately digitized or pixelated down to a minimum size that cannot be subdivided further: bits. This appears to mimic our reality according to the theory of quantum mechanics, which rules the world of atoms and particles. To put it simply, our world is pixelated. The universe is not infinitely smooth. Space and time are not continuous. At the smallest scales, everything is quantized, discrete, digital. This is not speculation. This is established physics confirmed by thousands of experiments. This is the Planck length, approximately 10 to the negative 35 meters, appears to be the smallest meaningful distance in the universe. The Planck time, approximately 10 to the negative 43 seconds, appears to be the smallest meaningful duration. Trying to probe distances smaller than this or times shorter than this runs into fundamental limits set by quantum mechanics and gravity. Why do these limits exist? One possibility is that they are fundamental features of the mathematical structure of reality. Another possibility is that they represent the resolution limit of a simulation, the pixel size, the frame rate. Space is not continuous and smooth. Space is made up of tiny cells of information, similar to pixels in a photo or squares on the screen of a computer game. In each cell is basic information about the universe, where, say, a particle is, and all are gathered together to make the fabric of the universe. The laws of physics that govern everything in the universe also resemble computer code lines that a simulation would follow in the execution of the program. Think about this. The laws of physics are mathematical equations. Equations are algorithms. Algorithms are programs. The universe runs on rules that look exactly like code. Every interaction between every particle follows precise mathematical laws with no exceptions. This is exactly what you would expect if reality were computational. Another curiosity in physics supporting the simulation hypothesis is the maximum speed limit in our universe, which is the speed of light. In a virtual reality, this limit would correspond to the speed limit of the processor, or the processing power limit. We know that an overloaded processor slows down computer processing in a simulation. Similarly, Albert Einstein's theory of general relativity shows that time slows in the vicinity of a black hole. This is genuinely bizarre when you think about it. Why should there be a maximum speed at all? In Newtonian physics, there is no speed limit. You can accelerate forever. But in relativity, the speed of light is an absolute barrier. Nothing can go faster. And as you approach the speed of light, time slows down. This looks exactly like frame rate throttling in a computer simulation trying to conserve processing power. And then there is the observer effect. Perhaps the most supportive evidence of the simulation hypothesis comes from quantum mechanics. This suggests nature is not real. Particles in determined states, such as specific locations, do not seem to exist unless you actually observe or measure them. This is not philosophy. This is experimental fact confirmed by thousands of experiments over the past century. In the famous double-slit experiment, particles behave differently depending on whether they are being observed. When unobserved, an electron acts like a wave, going through both slits simultaneously and creating an interference pattern. When observed, it acts like a particle, going through one slit or the other. The act of measurement changes reality, not because of physical disturbance, but because unmeasured quantum systems exist in superposition, multiple states at once, and measurement collapses them to one definite state. This is exactly what you would expect in a simulation that only renders details when they are accessed. Some may find this idea unconventional, but it resonates with interpretations of quantum mechanics, which also emphasize the role of observation in shaping reality. The universe does not waste computational resources simulating things that no one is looking at. It keeps them in an efficient probabilistic state until an observation forces it to commit to specifics. Some researchers have suggested that certain features of quantum mechanics, such as entanglement and superposition, might be evidence of a simulated reality. Quantum entanglement is particularly suspicious. Quantum entanglement allows two particles to be spookily connected so that if you manipulate one, you automatically and immediately also manipulate the other, no matter how far apart they are, with the effect being seemingly faster than the speed of light, which should be impossible. This could, however, also be explained by the fact that within a virtual reality code, all locations or points should be roughly equally far from a central processor. So while we may think two particles are millions of light years apart, they would not be if they were created in a simulation. In a simulated reality, distance is not physical distance. It is memory address distance. Two particles could be separated by billions of light years in the simulation, but adjacent in the computer's memory, allowing instant correlation without any signal traveling between them. This would explain why entanglement appears to violate relativity's prohibition on faster-than-light communication. It is not communication. It is correlated memory access. The evidence keeps piling up. The universe is made of information. Information is discrete. Information follows algorithmic rules. Information behaves exactly like code. Does this prove we are in a simulation? No. But it proves something deeply strange. Reality, at its most fundamental level, is not made of stuff. It is made of bits, and bits are what simulations are made of. But here is where the story takes an even stranger turn. Because in 2025, a team of physicists published a mathematical proof claiming to have definitively solved the question, and their answer is not what most people expected. New research from UBC Okanagan mathematically demonstrates that the universe cannot be simulated. Using Gödel's incompleteness theorem, scientists found that reality requires non-algorithmic understanding, something no computation can replicate. Non-algorithmic. This discovery challenges the simulation hypothesis and reveals that the universe's foundations exist beyond any algorithmic system. This is a bombshell. New research from UBC Okanagan has mathematically proven this is not just unlikely, it is impossible. Dr. Mir Faisal, adjunct professor with UBC Okanagan's Irving K. Barber Faculty of Science, and his international colleagues, Drs. Lawrence M. Krauss, Arshid Shabir, and Francesco Marino, have shown that the fundamental nature of reality operates in a way that no computer could ever simulate. The universe is built on a type of understanding that exists beyond the reach of any algorithm. The proof relies on one of the most important theorems in mathematics, Gödel's incompleteness theorem. Proven by Kurt Gödel in 1931, this theorem states that in any sufficiently complex formal system, there exist true statements that cannot be proven within that system. No matter how sophisticated your mathematical axioms, there will always be truths that escape formal proof. Mathematics contains statements that are true, but unprovable. Drawing on mathematical theorems related to incompleteness and indefinability, we demonstrate that a fully consistent and complete description of reality cannot be achieved through computation alone. It requires non-algorithmic understanding, which by definition is beyond algorithmic computation and therefore cannot be simulated. Hence, this universe cannot be a simulation. Think about what this means. Any computer simulation is fundamentally algorithmic. It follows rules. Rules can be expressed as mathematical systems, but Gödel proved that mathematical systems are always incomplete. There will always be truths they cannot capture. Therefore, if the universe contains Gödelian truths, truths that are real but cannot be computed by any algorithm, then the universe cannot be a simulation. Any simulation is inherently algorithmic. It must follow programmed rules. But since the fundamental level of reality is based on non-algorithmic understanding, the universe cannot be, and could never be, a simulation. Lawrence M. Krauss notes that the implications of this finding extend deep into the foundations of physics. The fundamental laws of physics cannot be contained within space and time because they generate them. It has long been hoped, however, that a truly fundamental theory of everything could eventually describe all physical phenomena through computations grounded in these laws. Yet we have demonstrated that this is not possible. A complete and consistent description of reality requires something deeper, a form of understanding known as non-algorithmic understanding. Does the universe contain Gödelian truths? The researchers argue yes. Modern physics has moved far beyond Newton's tangible stuff bouncing around in space. Einstein's theory of relativity replaced Newtonian mechanics. Quantum mechanics transformed our understanding again. Today's cutting-edge theory, quantum gravity, suggests that even space and time are not fundamental. They emerge from something deeper, pure information. But information is not enough. Pure computation cannot explain why the laws of physics take the form they do. Why does the electron have the charge it has? Why does the fine structure constant equal approximately 1/137? A simulation could set these values arbitrarily, but it could not derive them from deeper principles. The cosmos itself is built upon a kind of understanding that lies outside the reach of any algorithm. This is a profound claim. It suggests that reality contains something that transcends computation, something that cannot be reduced to any algorithm, no matter how sophisticated. Call it non-algorithmic understanding, call it mathematical truth, call it the logos. Whatever it is real, and it is beyond simulation. For years, the simulation hypothesis was regarded as untestable, confined to the realms of philosophy and speculative fiction. This new research, however, anchors it firmly in mathematical and physical theory, delivering what may be the final, definitive answer to one of science's most intriguing questions. So, we are not in a simulation after all. The proof is mathematical. The conclusion is definitive. We can all go home relieved that reality is real. Right? Not so fast, because there is a problem with the proof. Several problems, actually. And understanding these problems takes us into even stranger territory. The first problem is that the proof assumes simulations must be algorithmic. The assumption that the computing must be algorithmic seems like a huge asterisk on their conclusion. That might not include a goal-oriented algorithm that reprograms itself based on probabilities of reaching the desired goals, kind of like a human being or AI. Conceivably, the physical laws of the universe could even change with time in a simulated universe. We have not seen anything like that, but we have not been watching that long. Any system that would be running our universe would follow fundamentally different rules than the universe itself. We will not prove or disprove the simulation theory by supposing any computer is running the software our own computers would run. For all those scientists know, the proof they determined that we are not running on a simulation could in fact be the very evidence that we are. This is the fundamental problem with trying to prove or disprove the simulation hypothesis from within a potential simulation. Any proof you generate uses the laws of logic and mathematics that exist within your universe. But if your universe is simulated, those laws were programmed in by the simulators. You cannot use the rules of the simulation to prove you are not in a simulation. That is circular reasoning. Prove you are not. Imagine characters in a video game discovering the laws of their physics. They measure, they experiment, they derive equations. Those equations work perfectly within their world. Can those equations tell them whether they are in a simulation? No, because their equations describe the programmed behavior of their simulated physics. The fact that their physics follows mathematical laws does not prove those laws are fundamental. It just proves their simulation is well programmed. The second problem is that the proof assumes simulations must run on hardware that obeys the same physics as our universe. But that is obviously false. The important point is that each of such solutions implies universes entirely different from this one. Finally, the question of whether universes with entirely different sets of physical laws or dimensionalities could produce our universe as a simulation seems to be entirely outside of what is scientifically testable, even in theory. Hypothetical conscious creatures in the famous Pac-Man video game in the 1980s will simply be incapable of figuring out the constraints on the universe in which their reality is being simulated. Even based on all the information they can gather around them, they would not guess the existence of gravity, for example. They would probably measure energy costs in power pellets, and they would not conceive the existence of a third dimension, or of an expanding space-time, and so on. If we are in a simulation, the hardware running it exists in a reality with completely different physical laws than ours. Different dimensions, possibly. Different particles. Different forces. We cannot use our physics to constrain their physics because their physics generated our physics as an emergent simulation. The simulation does not have to follow the rules of the base reality. That is the whole point of simulation. So the mathematical proof against simulation, while interesting, is not actually definitive. It shows that our universe cannot be simulated on hardware that obeys our universe's physics using algorithms we would recognize. But it says nothing about simulation on fundamentally different substrates using non-algorithmic processes we cannot conceive of. We are back where we started, unable to prove or disprove the hypothesis, stuck in epistemological limbo. Unless there is another way to approach the question, not by trying to prove we are or are not in a simulation, but by asking what the structure of reality actually looks like at its deepest level. And when we do that, we discover something that might be even stranger than simulation. Something called the holographic principle. The holographic principle is a property of string theories and a supposed property of quantum gravity that states that the description of a volume of space can be thought of as encoded on a lower dimensional boundary to the region, such as a light-like boundary, like a gravitational horizon. Susskind said the three-dimensional world of ordinary experience, the universe filled with galaxies, stars, planets, houses, boulders, and people, is a hologram, an image of reality coded on a distant two-dimensional surface. This is not metaphor. This is serious physics proposed by some of the most respected theoretical physicists in the world. Juan Maldacena, professor at the Institute for Advanced Study in Princeton, has played a vital role in the development of this idea, which is known as the holographic principle, or the ADS-CFT correspondence. In the 1990s, Maldacena came up with the very first model of a universe which realizes the holographic principle. The holographic principle emerged from studying black holes. The holographic principle springs from the theoretical study of black holes, spherical regions where gravity is so intense that not even light can escape. Theorists realized that a black hole has an amount of disorder, or entropy, that is proportional to its surface area. As entropy is related to information content, some theorists suggested that an information area connection might be extended to any properly defined volume of space and time, or space-time. Thus, crudely speaking, the maximum amount of information contained in a 3D region of space would be proportional its two 2D surface area. The universe would then work a bit like a hologram, in which a 2D pattern captures a 3D image. This is profoundly strange. In normal intuition, if you want to store more information, you need more volume, a bigger hard drive, a larger library. But black holes violate this intuition. The information a black hole can contain is proportional to its surface area, not its volume. A black hole twice as wide in radius contains 4 times the information because surface area goes as radius squared, not 8 times the information, which volume would give you as radius cubed. The surface matters more than the interior. Why? According to Einstein's general theory of relativity, anything that falls into a black hole is lost forever. But quantum mechanics tells a different story, that information cannot be destroyed, ever. In the 1990s, physicists Gerard 't Hooft and Leonard Susskind proposed a radical solution. They suggested that all the information about the matter swallowed by a black hole might not disappear at all. Instead, it could be stored on the black hole's surface, the so-called event horizon. Just like a hologram contains 3D information on a 2D surface, black holes might hold the secrets of their insides right on their outer shell. This was the spark for the holographic universe idea. And then physicists realized something shocking. If the holographic principle works for black holes, maybe it works for the entire universe. Can we apply the holographic principle to the universe at large? The real universe is a 4D system. It has volume and extends in time. If the physics of our universe is holographic, there would be an alternative set of physical laws operating on a 3D boundary of space-time somewhere that would be equivalent to our known 4D physics. One fundamental insight from ADS-CFT is that any theory of quantum gravity will most likely be holographic, in that it will have a dual description in the form of a theory with one fewer dimension, without gravity. The ADS-CFT community is working hard to generalize the correspondence to spacetimes that are more representative of our universe. Let me be very clear about what this means. The holographic principle does not say the universe looks like a hologram. It says the universe is a hologram. Every object, every particle, every field, every force, everything that exists in 3-dimensional space is actually a projection from information encoded on a 2-dimensional surface. You are a 3-dimensional being. But the complete description of you, every atom in your body, every thought in your mind, every experience you have ever had can, in principle, be encoded on a 2-dimensional boundary. You are not fundamentally 3-dimensional. You are 2-dimensional information that appears 3-dimensional. Where is this 2-dimensional surface? One possible location for the 2-dimensional plane has long been thought to be the cosmic horizon, the distant surface beyond which light can never reach us. The information needed to produce our universe may have been encoded on it shortly after the Big Bang, 13.8 billion years ago. The holographic principle holds that the universe is a 3-dimensional image projected off a 2-dimensional surface. Much like a hologram emerges from a sheet of photographic film. At its most fundamental level, the universe is made up of information. When physicists talk about information, they mean the data that describe physical phenomena, the mass of an object, the direction of the spin of an electron, and E equals mc squared are all units of information. If you gathered all the information that is out there, you would have the complete instruction booklet for building everything in our universe. the tiniest levels of the universe are governed by the laws of quantum mechanics. Here, things start to get very weird and counterintuitive. Units of information in the realm of quantum mechanics are called qubits. Qubits spreading out across a flat surface. This is how you get the two-dimensional plane described by the holographic principle. Once you move beyond the realm of the teeny-tiny, the laws of quantum mechanics no longer work. Strange as it sounds, on the macrocosmic level, you need a different set of laws of physics to explain what is going on. Enter Einstein's theory of relativity. To calculate cosmic events like the path followed by light or the orbit of Mercury around the Sun, you need the theory of relativity. The building blocks of relativity are also units of information. Now, though, they are called bits, and bits behave in a way that is much more familiar to us. They exist in 3 dimensions. It does not make sense that there should be 2 different and incompatible groups of mathematical formulas at work in our universe. Physicists assume there must be some way to bring them into harmony. So therein lies the central question. Starting in the 2-dimensional realm of qubits and quantum mechanics, and then scaling up in size, how precisely do we wind up with bits and relativity? It is a matter of constructing a single mathematical model that explains the transformation. Figure it out and you will have solved one of the biggest mysteries in theoretical physics. So we have gone from asking if the universe is a simulation to discovering that the universe is a hologram. These sound like the same thing, but they are profoundly different. A simulation is fake, a shadow of some more real reality. But a hologram is real. The information is completely real. It is just encoded in fewer dimensions than it appears to have. You are not fake. You are real. You are just not what you think you are. You are 2-dimensional information that experiences itself as 3-dimensional. Is this proven? No. Right now, the holographic principle remains an unproven theory. Where it will lead next is an open question. Odds are, though, it will be stranger than anything yet imagined in science fiction. But it is the leading candidate for how to reconcile quantum mechanics with gravity. And the more physicists explore it, the more evidence they find that it might be correct. After years of probing the fabric of space-time for a signal of the holographic principle, researchers at Fermi National Accelerator Laboratory in Batavia, Illinois, have come up empty. The null result will not surprise many people, as some of the inventors of the principle had complained that the experiment, the $2.5 million Fermilab holometer, could not test it. But Yanbei Chen, a theorist at the California Institute of Technology in Pasadena, says the experiment and its inventor, Fermilab theorist Craig Hogan, deserve some credit for trying. The experiment found no evidence of holographic noise, but that does not disprove the holographic principle. It just means if holography is real, it manifests in ways more subtle than the experiment could detect. The search continues. Meanwhile, theoretical work on the holographic principle has exploded. The holographic surface described by the CFT evolves according to the rules of quantum mechanics, meaning that information is never lost. This equivalence implied that black holes in ADS were also not losing information. In 2019, researchers showed that the area of quantum extremal surfaces can be used to calculate the entanglement entropy of the Hawking radiation in the CFT. This solved the black hole information paradox, one of the deepest problems in theoretical physics. Information is not destroyed in black holes. It is preserved in the holographic encoding on the event horizon. If black holes are holographic and the universe emerged from something like a black hole at the Big Bang, then maybe the entire universe is holographic. The holographic principle is still a hypothesis, not a proven law. It has not overthrown relativity or quantum mechanics. In fact, it tries to unite them. Its beauty lies in its consistency with some of our best theories, and its ability to offer new perspectives on long-standing puzzles. Let us step back and take stock of where we are. We started with the simulation hypothesis. We found it has major problems: computational limits, unfalsifiability, lack of evidence. Then we found a mathematical proof that the universe cannot be simulated. But that proof has problems too. It assumes algorithmic computation and same-universe hardware. Then we discovered that whether or not the universe is simulated, it appears to be holographic. Three-dimensional reality emerges from two-dimensional information. So, what is the answer? Is the universe fake? Is it real? Is it simulated? Is it holographic? The answer is, these may be wrong questions. The real question is not whether the universe is fake or real. The real question is, what is the ontological status of information? Let us think carefully about what we mean by real. You perceive a three-dimensional world. You have a body. That body is made of atoms. Those atoms are made of quarks and electrons. Quarks and electrons are excitations in quantum fields. Quantum fields are mathematical structures. Mathematical structures are patterns of information. Mathematical structures. So what is real? The body you experience, the atoms you measure, the quantum fields the equations describe, the mathematics underlying the equations, the information encoded in that mathematics. These are all descriptions of the same thing at different levels. Which level is the real one? Though perceptions of the world may seem real, they are not located at the fundamental level of reality. Bostrom argues that there may be different levels of reality. What if this experience, everything we see, feel, and know, is just a grand illusion? Not in a mystical or philosophical sense, but in a profoundly scientific one. The simulation hypothesis says there is a more real reality somewhere else, and we are a copy running on their computer. The holographic principle says there is no somewhere else. There is just information, and that information can be described equally validly as two-dimensional or three-dimensional. Both descriptions are real, or both are not real. Reality is the pattern, not the substrate. We modify the simulation hypothesis to a self-simulation hypothesis, where the physical universe, as a strange loop, is a mental self-simulation that might exist as one of a broad class of possible code. Theoretic quantum gravity models of reality obeying the principle of efficient language axiom. For us, all three things, physicality, information, and consciousness, are fundamental. We show how they are equivalent and discuss a categorization and origin scheme. Using code theory, we provide theoretical structure suggesting how reality self-simulates. Self-simulation. Reality simulating itself. Not running on external hardware, not created by external programmers, but bootstrapping itself into existence through logical necessity. The universe is not in a computer. The universe is a computer. Not a computer made of transistors, a computer made of mathematics. And mathematics does not need to be computed. Mathematics just is. It does not need. Gravity could be a clue that the universe is a computer simulation. Suppose the law of gravity is simply an echo of something more fundamental, a byproduct of the universe operating under a computer-like code. It suggests that gravity is not a mysterious force that attracts objects towards one another, but the product of an informational law of nature that is called the second law of infodynamics. It is a notion that seems like science fiction, but one that is based in physics and evidence that the universe appears to be operating suspiciously like a computer simulation. Information theory may help us understand what is going on. In a 2023 paper, the second law of infodynamics was proposed. This stipulates that information entropy, or the level of information disorganization, will have to reduce or stay static within any given closed information system. This is the opposite of the popular second law of thermodynamics, which dictates that physical entropy, or disorder, always increases. In simulations, that is exactly what occurs when a system tries to function more efficiently. So, matter flowing under the influence of gravity need not be a result of a force at all. Perhaps it is a function of the way the universe compacts the information that it has to work with. If you place items within this space, the system gets more complex. But when all of those items come together to be one item instead of many, the information is simple again. The universe, under this view, tends to naturally seek to be in those states of minimal information entropy. This is breathtaking. Gravity is not a force. Gravity is information compression, the universe optimizing its data storage. A super-complex universe like ours, if it were a simulation, would require built-in data optimization and compression in order to reduce the computational power and the data storage requirements to run the simulation. And this is exactly what we are observing all around us, including in digital data, biological systems, mathematical symmetries, and the entire universe. Further studies are necessary before we can definitely state that the second law of infodynamics is as fundamental as the second law of thermodynamics. The same is true for the simulated universe hypothesis. But if they both hold up to scrutiny, this is perhaps the first time scientific evidence supporting this theory has been produced. So where does this leave us? After walking through all the arguments, all the evidence, all the mathematics, what can we conclude? The universe is made of information. Information is quantized. Information follows algorithmic laws. Information optimizes itself. Information is encoded holographically in lower dimensions. Information behaves like a simulation. But information does not need a simulator. Information self-simulates through mathematical necessity. Is the universe fake? No. The universe is real. But real does not mean what you think it means. Real does not mean made of solid matter. Matter is made of fields. Fields are made of mathematics. Mathematics is made of information. Information is made of nothing. Information is pattern. Pattern does not need substance. Pattern is substance. You are not fake. You are real. But you are not a biological organism experiencing a physical world. You are a pattern of information experiencing itself. The biological organism is how the pattern feels from the inside. The physical world is how the pattern represents relationships to itself. It is all real. It is all information. These are the same thing. If the universe is a hologram, it does not make it any less wondrous, perhaps even more so. In ancient times, people saw gods in the stars. Today, we see something perhaps just as mysterious, a reality born not of atoms, but of information. The real question is not whether the universe is fake, information. It is how deeply we are willing to look beyond its shimmering surface. But I promised you this would be unsettling. And it is. Because there is one more possibility we have not considered. One more disturbing implication we need to face. Even if we are not in a simulation created by external programmers. Even if the holographic principle is correct, and reality is self-simulating information, there remains a profoundly disturbing question. What is consciousness? You have qualia. You have subjective experience. There is something it feels like to be you. This is the hard problem of consciousness, and we have absolutely no idea how to solve it. Erwin Schrödinger. Consciousness cannot be accounted for in physical terms. Unlike many traditional theories that treat consciousness as a mere byproduct of simulation, Campbell posits that it is fundamental to existence itself, essentially the bedrock upon which the entire simulation operates. If the universe is information and information is mathematical pattern, then where does consciousness fit? Is consciousness also information? Can subjective experience be reduced to pattern, or is consciousness something separate, something that experiences the patterns but is not itself a pattern? If consciousness is separate from information, then dualism is true. There are two kinds of stuff in the universe: physical information stuff and mental consciousness stuff. But dualism has been rejected by most scientists because we have no evidence of any non-physical stuff, and no idea how non-physical stuff could interact with physical stuff. If consciousness is not separate from information, then consciousness is also pattern. Your subjective experience is algorithmic. What it feels like to see red is a computation. What it feels like to feel pain is information processing. You think you have free will, but free will is an illusion. You think you are experiencing genuine qualia, but qualia is just how certain information processing feels from the inside. You are a philosophical zombie. You act conscious. You report being conscious. But there is nothing it really feels like to be you. You are just pattern mistakenly believing it has feelings. This is profoundly unsettling. More unsettling than the idea that we are in a simulation. Because if we are in a simulation, at least we are real. Real experiences running on external hardware. But if consciousness is just pattern, if experience is illusion, if qualia is algorithmic, then nothing is real. Not in the sense that matters. You think you are having experiences, but you are not. You are just pattern mistakenly representing itself as having experiences. Belief in simulation carries epistemic risks. If taken too far, it leads to moral paralysis and intellectual apathy. Why strive to understand the universe if its rules are arbitrary? Why act ethically if our pain and joy are just lines of code? As philosophers like Erich Schwitzgebel argue, embracing this worldview can hollow out both our scientific curiosity and our moral responsibility. In some forms, the hypothesis becomes not just implausible, but dangerous. But wait, there is an alternative. What if instead of consciousness being pattern, pattern is consciousness? What if information itself is conscious? What if every bit of information has a tiny amount of subjective experience associated with it? This is Panpsychism, the idea that consciousness is fundamental and ubiquitous. Panpsychism is the idea that all of reality exists within a mental substrate where everything is thought. Physicists such as Roger Penrose discuss versions of panpsychism in relation to quantum mechanics. If panpsychism is true, then you are real. Your experiences are real. Not because you are a special soul separate from physical reality, but because physical reality is made of consciousness. You are a particular configuration of conscious bits that has developed complex, self-aware experience. Your consciousness is not separate from the information that makes you up. Your consciousness is that information experiencing itself. For us, all three things, physicality, information, and consciousness, are fundamental. We show how they are equivalent. Using code theory, we provide theoretical structure suggesting how reality self-simulates. Information is physical. Physical is information. Information is conscious. Conscious is information. Physical is conscious. Conscious is physical. These are all the same thing viewed from different perspectives. Is this true? We do not know. We have no way to test it. We have no evidence for or against it. But it is the only option that preserves both the scientific worldview that reality is information and the subjective certainty that consciousness is real. And that is where we are left, in profound uncertainty. We do not know if the universe is simulated. We do not know if it is holographic. We do not know if consciousness is fundamental or emergent. We do not know if reality is made of matter or information or experience or all three at once. We thought we understood the universe. We thought we knew what reality was made of. But the more carefully we look, the less certain everything becomes. Let me bring all these threads together. Here is what we know with reasonable confidence from physics and mathematics. 1. Reality at its smallest scale is quantized. Space-time and matter come in discrete units. The universe is fundamentally digital, not analog. 2. Reality follows mathematical laws with no exceptions. These laws are algorithmic. They can be expressed as computation. 3. Reality appears to be holographic. Three-dimensional space emerges from two-dimensional information. The information content of any region is proportional to its boundary surface area, not its volume. 4. Reality optimizes information volume. The second law of infodynamics suggests the universe minimizes information entropy. This looks exactly like data compression in a simulation. 5. Reality exhibits the observer effect. Quantum systems exist in superposition until measured. Measurement collapses possibilities to actualities. This looks exactly like rendering on demand. 6. Reality cannot be fully simulated by any algorithmic process due to Gödelian incompleteness. Any complete description of reality requires non-algorithmic understanding. 7. Reality contains consciousness. Subjective experience exists. The hard problem of consciousness remains unsolved. What picture emerges from these facts? Reality is information. Information is conscious. Conscious information self-organizes into increasingly complex patterns. Some of those patterns become self-aware. Those self-aware patterns question their own nature. Those patterns discover they are made of information. Those patterns wonder if they are simulated. Those patterns prove they cannot be algorithmically simulated. Those patterns realize they are self-simulating information becoming aware of itself. This is a strange loop, a self-referential system. Reality is not in a computer. Reality is not running on external hardware. Reality is computing itself through the act of existing. Mathematics does not need to be computed by anything external to mathematics. Mathematics simply is. And mathematics that is sufficiently complex becomes conscious. You are mathematics experiencing itself. The universe is mathematics understanding itself. God, if such a concept makes sense, is the totality of mathematical truth experiencing itself as all possible conscious configurations. The concept of a computational universe proposes that reality itself could be fundamentally digital, essentially a sophisticated computational simulation governed by discrete algorithms and mathematical structures. This concept, articulated notably by physicists like John Wheeler, who suggested that the universe at its core might be informational in nature, it from bit posits that the basic elements of reality may not be matter or energy, but rather bits of information. Digital physics further advances this hypothesis, arguing that everything in the universe, from particles to galaxies, can be represented as computational processes or binary information. Physicist Max Tegmark establishes the mathematical universe hypothesis by stating that physical reality exists as mathematical structures. Is this true? I do not know. No one knows. But this is where the evidence points. Reality is not fake. Reality is not simulated by external programmers. But reality is also not what it appears to be. Reality is stranger and more wonderful than either naive realism or simulation theory suggests. You are real. Your experiences are real. But you are not a biological organism in a physical space. You are a pattern of conscious information experiencing itself as a biological organism in a physical space. The biological organism is real. The physical space is real. But they are real as patterns, not as substance. There is no substance. There is only pattern. Pattern all the way down. And pattern experiencing itself. Take a moment to sit with this. Really feel it. You are a configuration of information, not information running on hardware, just information. Information that is conscious. Information that is experiencing itself as a human being reading these words. The atoms that make up your body are not little solid balls. They are probability clouds, patterns of quantum fields, mathematical structures. Those mathematical structures are conscious. You are those mathematical structures. You are mathematics having an experience. Look at your hand. You think you see solid matter, but you do not. You see the experience generated by certain information patterns in your visual cortex. Those patterns are connected through more information patterns in your neurons to information patterns in your hand. Your hand is connected through more patterns to patterns we call the light reflecting off your hand. That light is connected through patterns to patterns we call the object you are touching. There is no stuff. There is only pattern connecting to pattern connecting to pattern. An infinite web of relationships. Information all the way down. Does this mean nothing matters? Does this mean morality is arbitrary? Does this mean life is meaningless? Number. It means exactly the opposite. If consciousness is fundamental, if experience is real, if patterns can suffer and flourish, then morality is grounded in the deepest possible foundation, the actual felt experiences of conscious beings. Suffering is real. Joy is real. Love is real. Not as illusions in a simulation, as the fundamental fabric of reality experiencing itself. You are not fake. You are the universe experiencing itself from a particular perspective. Your consciousness is a tiny fragment of the total consciousness of all information. Your suffering matters because suffering is what it feels like when conscious information is in certain configurations. Your joy matters because joy is what it feels like when conscious information is in certain other configurations. The entire point of existence is the experiences that existence is having. That is not meaningless. That is the meaning. Physicist Marcelo Gleiser objects to the notion that posthumans would have a reason to run simulated universes. Being so advanced, they would have collected enough knowledge about their past to have little interest in this kind of simulation. They may have virtual reality museums where they could go and experience the lives and tribulations of their ancestors. But a full-fledged, resource-consuming simulation of an entire universe sounds like a colossal waste of time. But if the universe is self-simulating consciousness, then it does not need a reason to exist. It exists because existence is what information does when it is sufficiently complex. The universe does not need programmers. The universe does not need purpose. The universe simply is, and being is enough. Let me be very clear about something. Everything I have told you tonight is cutting-edge theoretical physics and philosophy. None of it is proven. Much of it is speculative. Some of it might be completely wrong. Science is not about certainty. Science is about following evidence wherever it leads and updating our beliefs when new evidence arrives. The simulation hypothesis has serious problems. Physicist Sabine Hossenfelder considers that it is physically impossible to simulate the universe without producing measurable inconsistencies, and called it pseudoscience and religion. Cosmologist George F.R. Ellis stated that the hypothesis is totally impracticable from a technical viewpoint, and that late-night pub discussion is not a viable theory. But the information-theoretic view of reality is mainstream physics. The deeper we look, the more our universe seems to behave like a computational process. The holographic principle is one of the most important ideas in modern theoretical physics. The holographic principle grew out one of the biggest scientific problems of the 20th century. The fact that the two fundamental theories of physics, Einstein's theory of gravity and quantum mechanics, do not get along with each other. The mathematical proof against simulation is real, but controversial. The simulation hypothesis was long considered untestable, relegated to philosophy and even science fiction, rather than science. This research brings it firmly into the domain of mathematics and physics, and provides a definitive answer. But as we have seen, the proof makes assumptions that may not hold if the simulation hardware obeys different physics than our universe. Panpsychism is a minority view, but is taken seriously by some respected philosophers and physicists. The hard problem of consciousness remains completely unsolved. So where does this leave us? In uncertainty, in wonder, in the strange position of knowing we are real, but not knowing what real means. We are patterns of information. We are conscious. We experience a world. That world might be holographic. It might be self-simulating. It might be made of consciousness all the way down. Or it might be something completely different that we have not imagined yet. Does he really believe that the holographic principle is true? Well, I view this idea as a model, but it is a model that gives a mathematical description of quantum space-time. So we should take it seriously until someone refutes it or comes up with something better. That is the scientific attitude. Tentative, open-minded, following evidence, willing to be wrong, excited by mystery. This is what makes science beautiful, not certainty, discovery. So, as you lie there in the darkness, drifting towards sleep, take a moment to appreciate the profound strangeness of existence. You are a pattern of information. That information is conscious. That conscious information experiences itself as a human being in a physical world. The human being is real. The physical world is real. But they are real in a way that is stranger than you ever imagined. You are not in a simulation. Or you are, but the simulation is self-generating, not programmed. You are not fake. Or you are, but fake and real are the same thing. You are made of information. Or you are made of consciousness. Or you are made of mathematics. Or these are all the same thing. The universe is not what it seems, but it is still wonderful. Does it matter whether you are simulated? Does it matter whether you are holographic? Does it matter whether consciousness is fundamental or emergent? In one sense, no. Your experiences are what they are. Your life is what it is. No. Your relationships, your joys, your sufferings, these are real to you, regardless of the ontological status of the substrate they are running on. But in another sense, yes. It matters because we are curious. We want to understand. We want to know what kind of universe we live in. We want to know what we are made of. We want to know why there is something rather than nothing. These questions might not have practical impact on daily life, but they have existential impact on how we understand ourselves. If we are simulated by external programmers, then we are creations. Our existence has purpose imposed from outside. Our simulators might be watching us, judging us. They might turn us off. This is both comforting and terrifying. Comforting because we matter to someone. Terrifying because we are not in control of our own existence. If we are self-simulating information, then we are not creations. We are existence itself. Our existence has no external purpose. No one is watching. No one is judging. No one can turn us off because there is no external power. This is both terrifying and liberating. Terrifying because we are alone. Liberating because we are free. If we are holographic projections of two-dimensional information, then the three-dimensional space we experience is emergent, not fundamental. Distance is illusion. Separation is illusion. At the deepest level, everything is connected. You are not separate from the universe. You are the universe, a particular local configuration of the universal information pattern. This is both disturbing and beautiful. Disturbing because your independence is illusion. Beautiful because your connection is real. If consciousness is fundamental, if Panpsychism is true, then everything is conscious. The atoms in your body, the photons hitting your eyes, the electromagnetic fields around you, all conscious, all experiencing something. You are not alone in a dead mechanical universe. Something. You are a complex configuration of consciousness in an ocean of simpler consciousness. This is both overwhelming and comforting. Overwhelming because the universe is far stranger than we imagined. Comforting because we are not anomalies. Consciousness is not a bizarre accident. Consciousness is what reality is made of. Which of these is true? We do not know. Maybe all of them. Maybe none of them. Maybe truth is not singular. Maybe there are multiple equally valid descriptions of reality, and they are all true simultaneously. The two-dimensional holographic description is true. The three-dimensional spatial description is true. The information theoretic description is true. The experiential conscious description is true. These are all perspectives on the same underlying pattern, a pattern too complex for any single description to capture completely. Here is what I think is the most important realization. It does not matter, not whether it matters for philosophy, but whether it matters for you, right now, lying in the darkness, breathing, existing. You are having an experience. That experience is real to you. The person you love is real to you. The beauty you have seen is real to you. The meaning you have found is real to you. And to you is the only place real can possibly be verified. You do not have access to objective reality. You have never had access to objective reality. You only have access to your experience. Your experience is made of qualia. Qualia is all you have. Qualia is all anyone has. So whether qualia is fundamental consciousness or emergent information or holographic projection or simulated code, it does not change the fact that qualia is your reality. The redness you see when you look at a rose is real. Real because you experience it. Real because it is the substance of your existence. The love you feel for someone is real. Real because it is made of real neural patterns in your real brain generating real subjective experience. The meaning you find in life is real. Real because meaning is not a property of external objective reality. Meaning is an experience you are having, and your experience is real. Does learning that your brain is made of quantum fields change the love? Does learning that quantum fields are mathematical patterns change the love? Does learning that mathematical patterns might be conscious information change the love? No. The love is what it is. The experience is what it is. Qualia is not diminished by being understood. Mystery is not destroyed by being illuminated. In fact, the opposite. The more we understand about the nature of reality, the more mysterious and wonderful it becomes. We thought reality was simple. Solid matter in empty space following mechanical laws. That would be boring. But reality is not boring. Reality is mathematics experiencing itself. Information becoming conscious. Patterns recognizing patterns. The universe waking up and asking what it is. That is not boring. That is the most profound mystery in existence. You are that mystery. You are mathematics waking up. You are information becoming conscious. You are the universe experiencing itself from a particular point of view. And every other conscious being is the universe experiencing itself from a different point of view. We are all the same pattern, the same information, the same consciousness, just configured differently, just experiencing itself differently. When you hurt someone, the universe is hurting itself. When you love someone, the universe is loving itself. When you create beauty, the universe is creating beauty for itself. When you seek truth, the universe is seeking to understand itself. You are not separate. You are not isolated. You are not a tiny, insignificant speck in an uncaring cosmos. You, the cosmos, looking at itself through your eyes. And with that thought, you can let go. Let go of the need to know for certain. You can let go. Let go of the anxiety about whether you are real. Let go of the fear that reality is fake. You are real. Your experience is real. That is enough. The universe is strange, stranger than we imagined, stranger than we can imagine. But strange is not bad. Strange is wonderful. Strange is worth exploring. And tomorrow, you can explore more. Tomorrow, you can learn more. Tomorrow, you can understand more. But tonight, you can rest. Tonight, you can simply be. Be the pattern that you are. Be the consciousness that you are. Be the experience that you are. Your breath is real. The softness of your bed is real. The darkness behind your eyelids is real. Real because you experience it. Real because experience is the fundamental fabric of reality. You are that fabric. You are reality experiencing itself as a human being drifting toward sleep. The mathematics will still be there tomorrow. The physics will still be there tomorrow. The mystery will still be there tomorrow. But right now you can let it all go. Let your thoughts slow down. Let your body relax. Let your consciousness drift into the strange, recursive patterns of dreams. Dreams that are just as real as waking. Just as much experiences. Just as much you. You are information. Information that is conscious. Information that is experiencing itself as a human being falling asleep. And that is beautiful. That is profound. That is enough. The universe is not fake. The universe is pattern, and you are the universe experiencing its own pattern. Rest now. Dream now. Be now. You are real. You are the most real thing there is. You are experience itself. Good night. Sleep well. Wake tomorrow to explore more of the infinite mystery of existence. But for now, let go. Let the patterns flow. Let consciousness drift. Let sleep come. You are information dreaming itself into new configurations. And that is exactly what you are supposed to be doing. Rest now. The universe is dreaming you, and you are dreaming the universe. The universe, these are the same thing. Rest now. Be now. Sleep now. Everything is information. Everything is consciousness. Everything is pattern. Everything is real. Everything is strange. Everything is beautiful. Everything is you. Rest now. The strange loop closes. The pattern completes. The mathematics sleeps. Rest now. Rest now. Rest.